Good morning, sixth grade. I'm recording your section 3.6 lecture. This is going to be shorter probably than the other ones because I have a second video I want you to watch that's going to show you a simulation of what the rock cycle looks like. So I'm just going to use the book images today. So if we go to the first image, as we're going along, two things I want you to be highlighting and making all the annotations that I've made. And likewise, I want you to do the 3.6 video check, which is this question based off of this video as well as the next video. All right, so we've talked about three different types of rocks, igneous, sedimentary, and metamorphic rocks. And now we're going to talk about the rock cycle, which says how these rocks, how this rock material moves from one type of rock to the other. It does take millions of years, so this is nothing that happens quickly, but given the right conditions, any rock can turn into, or any type of rock can turn into another type of rock, and does turn into another type of rock. All right, so next page. Your book gives one demonstration of one path, and I'm going to see if I can zoom in here. There we go. Your book gives one path through the rock cycle, and the example used by your book starts with rock forming below the Earth's surface into granite, or magma, I should say, forming into rock below the surface of the Earth. And that rock cools slowly and becomes, or that magma cools slowly and becomes granite. And so this granite they're talking about is what's forming this mountain down here, which is in Atlanta, called Stone Mountain. And as this rock reaches the surface of the mountain, animals, weather, wind, water cause this rock to break apart, form sediment, and rivers and whatnot, or even the wind, carry these bits of sediment to other areas where they collect and form layers, and eventually form sedimentary rock. And they talk about this granite particles of the, or quartz mineral particles from the granite weathering off the mountain, settling in one area, and then eventually forming sandstone. So sandstone would be our second type of rock that was formed by the same material, and that's a sedimentary rock. And then the third thing that would happen is that sandstone is going to undergo intense heat and pressure, either from layers upon layers going on top of it. It's going down further into the crust as more layers are added. Likewise, tectonic plate movement, which we'll get to later on, is causing the rock to bend and have more pressure put on it. And so as a result of intense heat and pressure, that sandstone is turned into a third type of rock, metamorphic rock, and it becomes quartzite. So I do want you to make sure that you've written this in, and I show the progression from granite, which is an igneous rock, and as a result of weathering and erosion and deposition, it becomes sand, which ultimately forms a sedimentary rock. And then that sedimentary rock undergoes intense heat and pressure for various reasons and becomes quartzite, which is a metamorphic rock. And so again, this is only one path that rock can take through the rock cycle. It's not the only path. And I've also answered, here, let me zoom back in. All right, it says, does the rock cycle stop after the quartzite has formed? So after that rock becomes metamorphic rock, goes from igneous to sedimentary to metamorphic, does it stop there? And the answer is no. That metamorphic rock could reach the surface and again undergo weathering and erosion and deposition and form sedimentary rock. Or that metamorphic rock could be continued to be buried further and further under the crust and eventually melt back into magma and that magma then ultimately will become igneous rock once it cools. So metamorphic rock is not like the end of the line, it's just another stop along the way of the rock cycle. I do want you to complete this in your book, and this diagram is showing the different processes that are going to create the different forms of rock. So we have igneous rock here, which can be turned into sediment as a result of weathering and erosion. And then as a result of deposition, that sediment becomes sedimentary rock. And this basic cycle that we're talking about here is what we just looked at with the mountain in Atlanta. This sedimentary rock undergoes heat and pressure, becomes metamorphic rock. Then that metamorphic rock may get buried further down, melt back into magma, and the cycle begins again. But as you see, we could have gone directly from igneous rock to metamorphic rock. So if I applied intense heat and pressure to this igneous rock, it would go straight to metamorphic rock. It wouldn't have to go through the sedimentary rock phase. Just the same way with the sedimentary rock. The sedimentary rock doesn't have to become metamorphic rock. That sedimentary rock could have could have buried to the point that it got turned back into magma and melted back into magma, and then again we start here with igneous rock formation from the magma. Like we said before, that metamorphic rock could go through weathering and erosion and again go back into sedimentary rock, and even sedimentary rock can be weathered and made back into different types of sedimentary rock. Okay, so the point is that there isn't just one path through the rock cycle, that all rocks can kind of become a different type of rock just based on the elements that they are exposed to. Here's where your book talks about tectonic plate movement. So I'm going to go through this not quickly, but we will cover this much more in 8th grade. But basically the point of tectonic plate movement, and I feel like maybe we talked about this in the first or the second section. The Earth's crust is made up of plates, and these plates rest on the liquid layer of the mantle that we know to be liquid rock, magma, and that magma is constantly moving inside the mantle. And the movement of that mantle causes the crust, the plates on the crust, to move. And it's this movement of the plates that really drives the rock cycle. And so I'm not going to go through it in depth because your book covers all the different ways in which the tectonic plate movement can cause the rock cycle to keep moving rock material through it. But one example they give, okay? So here let's talk about oceanic plates. Oceanic plates, where they meet up under the ocean, typically are going to move apart. So where two oceanic plates come together, they're going to typically move apart. And in that, as they move apart, there's almost like a crack in the crust, and that liquid rock seeps up through the crack and hardens and forms igneous rock. That's one place where igneous rock is formed. And this is the question for your quiz, those areas where the two plates move apart and I have magma seeping up and forming igneous rock is called a mid-ocean ridge. There's a large one that runs almost the entire way of the Atlantic Ocean from pole to pole, and it's called the Mid-Atlantic Ridge. But these happen in other oceans as well, and in general they're just called mid-ocean ridges. All right, so that's one example of the tectonic plate movement taking part in the rock cycle or driving the rock cycle. But one other thing I want to point out is that as these minerals move through the rock cycle, no matter what path they take, that rock material is never created or destroyed. It simply changes forms. It simply changes forms from one type of rock to another. All right, so that is the end of your section. I'm going to also post a video. This is what the video looks like. You're going to watch this video. It is a good simulation of what happens in the rock cycle. And then make sure that you do the 3.6 video check. Make sure you do the 3.5 open note quiz, which I have all the materials for 3.5 loaded, including my lecture, my Google slide presentation, the book images. So use those when you take the quiz so that you get a good score. And then finally, I have the metamorphic rock activity, which at this point, you guys should feel comfortable with the metamorphic rock activity, this virtual lab. It's just the same as the sedimentary and the igneous one that we've already done. You each have a copy. I've already uploaded the images for you. And so what you're going to tell me about these rocks is, number one, what did this rock come from? Or what was the parent rock of this rock? Because remember, metamorphic rock is rock that at one point was another rock. So in each of these cases, these rocks are formed from another rock. And I want to know what that rock was, or what rocks it can form from, because sometimes there's more than one. Then you need to tell me, is it foliated or non-foliated? Because remember, that's the way that we categorize metamorphic rock. And then also, what do we use these rocks for? What are some uses? So go ahead and you'll just do it on here, just like you did with the sedimentary one, and turn it in. And that's it. Looking ahead, we're going to have our assessment on this portion of Chapter 3 from Section 2 to Section 7 on Wednesday of next week. So tomorrow when I see you in class, we'll talk a little bit more about that, but I just want you looking ahead to see that we're going to have the assessment next week. Obviously, you'll have all of your materials that you can use. It's going to be open note, open book, so there's no reason to memorize all of this, but just make sure that you understand it. Okay, that doesn't mean open book, open note does not mean don't study. You still need to look it over, you still need to study and make sure you understand all of this so that when you're taking the test, it's not the first time you're looking at it. Okay, I hope you guys are doing well. Remember, we have our Zoom meetings tomorrow. I'm going to have, remember, Course 1, you're at noon, and Course 2, you are at 12:30. And if you can't remember where to go to get that link, remember, I put it on the Science Classroom right here, Zoom link for Thursday's class. So this is Course 2. It's right here. In Course 1, yours is in the same place. So Course 1, you're at noon. Course 2, you're at 12:30. All right? I hope you guys have a great day, and I look forward to seeing all of you tomorrow. If you have any questions, you can email me or put it on our doc, and I will respond. All right, guys, have a good day.